This is 11.4a of geometry. So we're going to start talking about volume. Okay, volume takes up 3 dimensions. Hopefully you know what volume is. If not, there's a definition up there and an explanation. We're working in cubed units because you got to go 3 different directions. Okay, so inches cubed, feet cubed. You could say cubic inches, cubic feet. Doesn't matter. So there's this principle. Cavalier's principle. Sorry, I don't know who that is, but he did a great job with this principle. It says if 2 space figures have the same height and the same cross-sectional area at every level, then they have the same volume. So, looking down here, if these have the same height, okay, and when we take a cross-section at any point, they have the same areas, then they take up the same amount of volume. So, if this one has the same height with this one, okay, and their cross-section is both the same area, then, even though they're different shapes, they're going to take up the same amount of volume. Okay, how much you could fit in there. Okay, in general, the volume of a prism is the area of the base, that's why it's a capital B, times the height of the prism. Okay, this works for any shaped base. If we are specifically talking about a rectangular prism, volume is length times width times height. Okay, they give you a generic equation for the volume because then you don't have to memorize a different volume equation for every single shape, right? If you want to memorize this, go for it. You don't have to. You'd be able to use this one. So, let's try using it. So, we're going to find the volume of this rectangular prism. So, I'm just going to use a generic one. V equals BH. So, the area of the base, here's my base down here. It's a rectangle. Remember, the area of a rectangle is length times width. So, I'm going to do 5 times 3, which gives me 15, and we're working in feet, so feet squared. I'm going to plug that in up here. So V is equal to 15 times, and then the height of the prism, which is 4 feet. And that gives me 60 feet cubed, or 60 cubic feet. Okay, so now we're going to look at triangular prisms. Your book does one that isn't a right triangle, okay, and we got to get into all of this. Or you could use some SOHCAHTOA in there as well. But we're going to do one that is a right triangle. So, remember, volume is equal to the area of the base times the height. So first we got to find the area of a base. Well, our base is a triangle, right? And it's a right triangle. So we can use 1/2 base times height. And this height is just the height of the triangle, not the height of the prism. Right? Here's my base. So it's 10 and 6 are the legs. So 1/2 times 6 times 10. Well, 6 times 10 is 60, and half of 60 is 30. So that's 30 meters squared is the area of the base. So 30, and then we got to plug in the height. The height is 5. The height of the prism, remember. So that gives us 150 more in meters, so meters cubed. And there's your homework.